Solve the absolute value of 2x plus 3 is equal to 2. I'm going to graph what this looks like first, just so we can see how many solutions there are, because that's one important thing with these absolute value equations. So thinking about what this looks like, what does y equals 2x plus 3 look like? Well, that's a diagonal line, a straight line coming down through here. And then if it was just y equals 2x plus 3, it would carry on going down there. But because it's the absolute value of 2x plus 3, we know it's going to reflect those bits up like this. It has a y-intercept at 3, and we could find the value of that point there as well, but we don't actually need it. And when is that equal to 2? Well, that's when that's equal to the horizontal line that goes through 2. So this is y equals 2. So we can see from here there are 2 points of intersection between these two functions. That means we're looking for 2 possible solutions to this equation. So how could we approach this? Well, there are 2 different approaches we could take. The first approach is to square both sides. If we square both sides, that gets rid of the fact that the absolute value is making things positive, because the square makes everything positive. When we do that, we get 4x squared plus 12x plus 9 is equal to 4. 4x squared plus 12x plus 5 is equal to 0. And then factorize that to solve it, or use the quadratic formula if we need to. We can do this with 2x plus 1 and 2x plus 5, which means that x is equal to minus a half, or x is equal to minus 5 over 2. So that's one method. Another method you could use to solve this is using the fact that if the absolute value of 2x plus 3 is equal to 2, that's the same as solving when 2x plus 3 is equal to 2. That's this solution here, when 2x plus 3 is equal to 2. It's also the same as solving when minus 2x plus 3, that's this one here, is equal to 2. That's this point of intersection here. Or, generally speaking, we would write this as 2x plus 3 equals minus 2. Either of those are the same, saying the same thing. And then we have to solve both of these individually to get our 2 solutions. So 2x is equal to minus 1, x is equal to minus a half. And on this side, 2x is equal to minus 5, x is equal to minus 5 over 2. And we get the same pair of solutions. When x is equal to minus a half and when x is equal to minus 5 over 2 is when these graphs intersect, and those are the 2 possible solutions for this particular equation. So you have a choice. You can either use the squaring method or the splitting it up method. My personal preference is the splitting it up method. The problem with the squaring method is if there's a negative somewhere in there, it can get rid of that negative. So you can end up with extra solutions sometimes. So you do have to be a little bit careful, but most of the time it's going to work absolutely fine. But I would recommend drawing a quick sketch, because it does help you see how many solutions you're expecting to get. And that makes it easier to know if you've gone wrong somewhere along the way.